Alright, so now we have a lot of the blanks filled in, vertical, horizontal, all the asymptotes, intercepts. Now we're going to see how it all goes together for the graph. Okay, so if I look at this first example, I'm going to go ahead and draw on an XY axis. Alright, now let's go through each little piece. So vertical asymptote at x equals 2. Alright, so remember asymptotes are going to be dotted lines. Okay, horizontal at y equals 1. X-intercept at 1, 0, and y-intercept at 0, 1/2. Okay, so now if you think about this function, there's really only one place for it to go. If you have a horizontal asymptote guiding it this way, an x and a y-intercept, you can see that this is going to be a shape like this. Now if I go on the right side of x equals 2, I have two choices technically. I could be up here, so I'm going to do it in yellow. This is actually not correct. So I could do something like this. Now that yellow is not correct. Think about this. The yellow crosses the x-axis right here. So that part right there is not possible. There's only one x-intercept at 1, 0. So the yellow, not a good graph. So the only way for this graph to go would be up here. So all of the red is the correct. Now what I want to introduce is a little bit of new notation. So we can agree that the red is correct, and if you want to grab your calculators and graph it, let's make sure you're okay. But let's say we're unsure, and there's going to be some times when we don't really know what's happening. We have a little bit of new notation here. Take a look at what I'm going to write here. As x approaches 2 from the negative direction. So now I'm choosing 2 because that's the vertical asymptote. So when I test things here, I'm always choosing the vertical asymptotes. So 2 from the negative direction. So now I want you to think of a number barely to the left of 2. So let's consider a number like 1.9. Okay, that's almost a 2, but just barely to the left of it. And you're going to plug it into the original function. So if I do that, in the top, I get 1.9 minus 1. I get a positive number. Over 1.9 minus 2, I get a negative number. What that means is, just to the left of 2, it's going to be negative. In fact, it's going to go to negative infinity. So what I mean is this. When I approach 2 from the left, so I'm going to trace over the red now. I'm approaching 2 from the left, it's going to shoot down to negative infinity. Alright, let's do the same thing from the right of 2. As x approaches 2 from the right side, okay, so a number really close to 2 but barely on the right would be like 2.1. Alright, let's plug it in. 2.1 minus 1 is a positive number. 2.1 minus 2, another positive number. Alright, so two positives make another positive, so it's going to positive infinity. Okay, so now let's trace over the red again. So I'm approaching 2 from the right, and it shoots up to positive infinity. Alright, let's try a little more complicated example. Look at number 2 here. Alright, so first things first. Let's draw on the vertical asymptotes. X equals negative 2. And x equals 1. Y equals 2 for horizontal. Okay, now x-intercepts at a 1/2, 0 and negative 4, 0. And y-intercept at 0, 2. Okay, now let's do the same thing. So I can kind of visually see that as I approach the first vertical asymptote from the left down to negative infinity, as I approach this vertical from the right up to positive infinity, and again, let me do that funny yellow color again. So that yellow color is incorrect. So the reason I can't be this yellow is because it would create an x-intercept that's not there. So this yellow is no good. Okay, so the red is correct. Then if I look at the red in the middle, I would see, oh, I'm not quite sure. Does it start high and go low? We're not quite sure. So let's try a couple things here. Let's go as x approaches negative 2 from the right. Okay, so that would be a number like negative 1.9. All right, and if I go and plug it in, negative 2 from the right goes up to positive infinity. That means negative 2 from the right is going to start up here, positive infinity. And then if I do the same thing, if I approach positive 1 from the left, and I do all the plugging in, it goes down to negative infinity. So it continues down. So again, all the red is the correct graph. Now looking at this page, we have two more examples that are kind of similar to the first two. So what I want you to do is I want you to hit pause. I want you to try to graph those two examples and then check them on your calculator. Alright, now it's time for a slant asymptote. Let's see how these look. So if I look at this example, number 5, let's go ahead and draw in. I'm going to draw the axes in the middle. And then I'm going to go ahead and draw the verticals, 1, 2, 3. Okay, now the slant is graphed, the slant asymptote is graphed just like any old line. So it's got a y-intercept of negative 1, up 1 over 1. So here's how I would graph the slant asymptote. Okay, now I have x-intercepts at 5, 0, negative 1, 0, and then y-intercept at 1 2/3, about there. Okay, now keep in mind, these dots on this slant asymptote are not part of the graph. They just helped me get the line in place. Now if I look, you can kind of see what's happening. I can see that this guy is going to swoop in like this, and that this one's going to swoop in like this. Okay. Alright, the next slant asymptote, there's a little bit more going on, so I want you to give it a shot. Be really careful with your x-intercepts, and then again, check it on your calculator, and we can talk about it in class tomorrow. Okay, the last two examples involve having a hole in the graph. Now remember, a hole is created when you have a factor that crosses off like this. So those two crossed off, so that's going to create a hole. So I'll kind of show you how we go in and do that. But first thing, let's go ahead and do the verticals just like we did on the last few examples. So vertical at x equals negative 1, horizontal at y equals positive 1, x-intercept at negative 3, 0, y-intercept at 0, 3. Okay, now I can kind of see what's happening here. I'm going to go ahead and sketch it in. So we have one piece of the graph that's down here. We have one piece that's up here. Now what we need to do is we need to account for the hole in the graph. Okay, so if I account for the hole in the graph, whoops, and I come over to x equals 1. X equals 1 is about here. So if I had an eraser, if I could find the eraser on here, x equals 1, if I can erase a little piece of this graph here, let's see, and I come in with blue, there would be a hole right here. So take your eraser and make sure you put a hole in that graph. Alright, not quite sure how to get rid of this arrow on my screen, but here's one more example that has a hole in it. So you go ahead and give it a shot, fill it in, and then we'll check it in class.